We talked last class quite a bit about compiled object-oriented languages, what this is, what's the difference between a compiled language and interpreted language, C# specifically, some of the advantages and why we're going to use C#. Today I want to go more broad rather than specific on C#, more broadly talk about some object-oriented concepts. Now, you guys have been in some of my other programming classes where we've talked object-oriented. Andrew, you may have picked these up elsewhere. So some of this might be a review, but I want to make sure that we hear it because you may not have heard it this way. Okay? Talking about these things as kind of the foundation, the structure of what we're doing in programming. Okay? Object-oriented programming. Okay? Obviously, as the name would imply, object-oriented programming deals primarily with thinking of things in code as though they are objects. Objects kind of fit with our real-world understanding. We know what an object is. An object has properties and methods. Properties are the things that it is, right? The attributes of the object. Some of them are changeable, some of them are set. Okay? This is blue. I could change that property by painting it, right? Okay. It has a particular length, width, and height. Suppose I could change that either by crushing it or moving it. Okay. It is metal. Can I change that? Transmutation is a bit beyond my skills and powers. Okay. Now the property of being metal, I can make it cease to exist, but I can't change that property. So some things are immutable, some things are mutable, changeable versus unchangeable. Methods being things that the object does. Sometimes those are very complex, sometimes those are fairly simple. Sometimes they directly influence properties. Okay? I might have a method that changes a property of an object. But we can kind of interact with the physical world, thinking about objects being properties and having methods. We're going to start to think about objects in code in a similar way. Okay? An object, any article, entity, or concept in the real world represented in code. The concept is the tricky one there. It's easy for us to hold up a physical object and say, okay, I want to model this in code, right? But what about an abstract concept? Okay? What about an integer? Can I hold an integer? I really can't hold an integer. And yet an integer is a concept that does have properties and methods. Okay? Can I assign a value to an integer? And that would be a property of the integer, right? Okay? Could I get the integer to report its length? How many digits are in there? Okay, that's another property of an integer. Then can I do something on that? Can I make a function to round that integer, add that integer, multiply? Gets a little bit. Round that integer to the nearest 10 or the nearest 100. Okay. You were thinking decimals. That was very... I want to round it to the nearest one. We do round things other than just to a non-decimal value. Okay, so object, any entity, any concept that we are going to put into our code becomes this object. As I said, objects have properties and methods. A value that describes an aspect of an object, that's the property, it's descriptive. Think adjectives or nouns. Versus the method, a function or process that an object can perform or that can be performed on it. Something you can do to it or something that it can do, that's going to be our method or our verb. Okay? That kind of creates this framework, and we've looked at that if you've done something like Python, Visual Basic. Oftentimes we've accessed the text property, the length property. We've done things like .toUpper or toLower in order to make string uppercase, lowercase, right? So we've touched on these things. Okay? But we may not have focused on them as the structure of our code in our program. Okay? Objects are defined by their class. The class essentially says, this is what an object of this type should look like. These are the properties that it should have. These are the methods that it should have. It doesn't necessarily fill in all of the values for those properties. Okay? So this might be part of the switch class. Just happen to have these sitting here. These both are part of the switch class, right? They've got some similarities and differences. The switch class, one of the properties might be number of ports. The class defines that a switch has the property number of ports, but it doesn't necessarily say what that number is. 16 and 5, right? We've got different switches with different values for those properties, but they all have that property. Does that make sense? So the value that goes in that property is not necessarily defined by the class. It can be if there is a default value or an inherent value for that. But the class defines what the properties of that object are, as well as the methods that are part of that. Then I can create as many instances of an object as I want. Some of the other classes, we do the bouncing ball project, right? And a ball has an X and a Y location. And I can create 100 balls that all follow the same class description, and they all have an X and a Y location that is unique to their particular object, right? Okay? All right, an instance is a single representation of an object of a given class. Right? Is that nomenclature all familiar? You've seen that somewhere else, or you've heard it, makes sense? Okay, awesome. Okay. Okay. Some of the advantages of object-oriented programming come in the way that we're kind of getting code grouped and organized in a way that is both transportable, transferable, and reusable. Abstraction is hiding the details and only revealing what is necessary. So an object might have a property that is rather complex. Rather than having all of that complexity either visible to the user or visible to the programmer who's using that object, we might hide some of that behind a rather simple function so that we don't have to look at all of the interesting pieces. The example there, an object may return a calculated value from a .get method without revealing how the method determines that calculated value. If I have an object that represents, for example, a loan, and I say get the value of the principal, right, well, that may actually be calculated from the original loan value, the interest that has accrued minus the payments that are there. There might be a rather lengthy process to get to what the principal of the loan is today, but we don't need to see that, right? I just want to know what it is. By encapsulating data or by abstracting the information inside of an object with a method, we just see what we need to see. We don't really care about how it gets there. Okay? Encapsulation, wrapping similar code or objects together. This is most often used in classes that define multiple objects. Objects are going to have a similar class, and we can have a hierarchy of class that things inherit from. But by creating this encapsulation, we can more easily move code from section to section to section, right? From program to program, code to code. A lot easier if it's all self-contained and what we call encapsulated. Inheritance. Now, this is where the hierarchy of classes come into play. Just as an object can be a member of a class, classes can be members of classes. We call things that are inheriting from other classes subclasses, superclasses being the thing that we're inheriting from or that might encapsulate other classes. Think about this for a moment. There are a variety of people at Emmaus that have different roles, right? We've got faculty, we've got staff, we've got students, we've got kitchen workers, we've got visitors. Are they all people? We're pretty sure, okay? So we're not necessarily going to give attributes to the student class that really are part of the people class if we were trying to create a system that modeled all of the people at Emmaus Bible College, right? We would create a person class, perhaps, that might have things like age, gender, birthday. That's not a unique attribute of a student or a unique attribute of a faculty member. It is a unique part of a person. Then we might have student, and student has a schedule that they have to keep, a grade point average. Okay? Aspects of them being a student that staff doesn't necessarily have a grade point average, faculty doesn't have a grade point average, right? But we would inherit all of the properties of a person from the person class inside of our student class, inside of our faculty class, inside of our staff class. Does that kind of make sense? We create this hierarchy of properties and methods. And as we get more specific classes, we get more specific properties and methods to that specific object. Okay? Inheritance is an advantage of object-oriented programming. Polymorphism. Who can tell me what polymorphism is? Eli's like, I can read a slide. Yeah, this is the word that we don't usually mention or talk about. We talk about class definitions, we talk about methods and whatnot, but polymorphism is a big scary word, isn't it? What in the world does it mean? We don't use that in normal language. It's like shape-shifting, like morphing, like what's going on? Okay? Polymorphism allows objects to override superclass definitions or provide alternative function definitions. The idea being, if I have this hierarchy of classes, okay, and maybe there's a property up in one of those higher classes that in this specific instance, even though it's part of this bigger whole, it doesn't make sense or it's different than the way that it's used in this bigger whole. Okay? And so we might override that in a subclass. More commonly, and the way that you guys are going to see it in this class, is writing the same function with the same name, but it takes different inputs and therefore does something different. I think I've got a slide. Yeah, okay. So I've got these guys here. If I want to just draw a shape, okay, I've got some function for drawing a shape. It draws an arbitrary shape. But I've got a circle and a square that are going to override the shape drawing function to draw specifically a circle or a shape. Okay? This is what I just mentioned over here. I have a math utility. Okay? I want to add two numbers. Well, are they integers or are they double? Are they floating point numbers? I may not know that. So I've created two identical functions. Okay? One is called add, the other is called add. They have the exact same name. If I pass it two integers, it's going to take two integers and it's going to return an integer back. If I pass it two floating point numbers, it's going to do the exact same thing. Notice they do exactly the same thing, and it's going to return a floating point number. Right? This becomes important in strongly typed languages where we can only give it certain information, and if we give it the wrong information, the code breaks. Right? Okay? So polymorphism, two functions of the same name. At compiler time, the compiler will actually choose the one that is correct based on what's being passed to that function. Okay? Different subclasses override the basic draw method that's there. Both of these allow objects to act in many different ways. Polymorphism. And now that's a less scary word, I hope. Okay? For the next several class periods, next several weeks in fact, we're going to be authoring code in Visual Studio 2022. I throw this up here because those that have had some of my other classes like Visual Basic, we use the GUI version of Visual Basic and we build GUIs with buttons and text boxes and things like that. We're going to use console applications in this class, even though C# has the ability and the form designer to do GUI. The primary reason is for starting out, this is how much code it takes to do a hello world versus how much code it takes to do a hello world with a GUI. It's not that much different, but there's just a lot of extra in the GUI side that we don't have in, like Visual Basic is very clean. You don't see a lot of the auto-generated stuff. C# it's a little bit messier. So we're going to do console applications just for the sake of simplicity, as well as to kind of develop some of our skills with thinking about user interaction and stuff like that. We're going to do console applications. Towards the end of the semester, if we're having fun and we're sick and tired of console, we may jump over to GUI. It's not a difficult thing to move that direction, but I don't want the GUI stuff to confuse you right now. Okay? I don't want to get lost in the GUI. I'd much rather work on code. So we're going to use console applications instead of GUI. That being said, why don't we go ahead and open up Visual Studio 2022, not VS Code, but the purple Visual Studio. Everybody should have a Visual Studio window that looks something like this. and we're going to click on Create a New Project. Okay. Then make sure that up in these three drop downs here, we have selected C#, not Visual Basic, and not anything else. This is just going to filter the different project types that are here. Okay. And we should have a console app somewhere near the top. Okay, and that's what we're looking for. A little C# icon, console application. And we can select that. If you want to play around on your own with the GUI side of things, the C# Windows Forms app, that'll give you a form designer that you can kind of use to build a graphical interface similar to what we do in VB. But we're going to do console app. Okay. I'm going to click Next. Give the project a name. This one, well, let's just go ahead and call it Hello World because that's the big thing that we're going to do in it. All right. Then I do want to save it in a location that I can find later. So I'm going to hit that Browse. You'll notice that by default it puts me inside of my Documents folder, Source, and Repos. I am going to go over to Emmaus where I have a folder for this class. And I'm going to create a new folder for in-class projects 2024. Then I can click Next. The framework should be .NET 8. It's not a big deal if it's something else, but it should be .NET 8. We can click Create. Okay, I'm going to come back to that in just a moment because I wanted to show you guys where that ended up being created. Yeah, well, we'll dive into that in just a minute. And actually, I'm somewhat bothered. Okay, we'll look at that in a minute. All right, make sure that you know where that's saved. So I'm navigating to that same Emmaus folder, the folder I have for this class, in-class projects 2024, and I have a Hello World folder sitting there. You will need to know where this is because when you go to turn in your C# projects, it is this folder that you're going to need to zip into a compressed folder and then upload to Schoology. So I just want to make sure everybody found their Hello World folder. Okay. And it has another Hello World folder in it and a hello world.solution. The solution file, by the way, is what you would want to open up if you were trying to open this project specifically, but it needs both the supporting folder and the solution file all in that one folder. Okay. We'll look at that a little bit more. Now, the interesting thing about this is not only did it just do our code for us, it also truncated all of my directives.
It was in the create. When you create the solution, when you choose the framework, you got to check the box that says do not use.
Okay, let me run through that real quick. So, creating a new one. Hello World console. Put that, oops, it should be in my drop downs here. Cool, 24. Ah, there it is. Thank you, Eli. All right, we're gonna have to be careful on that one. And yes, if you have not already created a new project with that checkbox checked, what was that called? Do not use top-level statements. Check that box. So you may notice there is a global using directives that has all of these different things in here. Normally that would show up right here. Normally we would have directives at the top here, which define namespaces we can use. And can you guys read my texts well enough, Eli? Yeah, okay. So it would be like using system would be one of those directives. That includes functions like read and write. So we don't have this write line unless we have using system. Now it's going to tell me that this is a useless line because our global directive already includes system and system.io. You'll notice link for database and even some of the threading stuff. By default, these are all the ones that are included in the project. Okay. We may later have directives that we need to add, and that's where we would add our own directives. Okay. For right now, I'm just going to comment that out. The double slash is a single line comment, by the way, and the slash star slash, or I'll actually do it up here, multi-line comment. Okay. Single line, multi-line comments, directives usually up the top. Okay. Now, what is a namespace? Put a comment here. So a namespace is a grouping of related code elements. For our projects, we're typically going to have one namespace that is a collection of all the code for this particular project. But as you can imagine, you get into larger and larger projects, you might group utilities together, aspects of the code together into different namespaces so that you can organize things. So it is a collection of classes. You might want to think of it that way, a collection of common elements. All right. What's the difference between the namespaces that we use inside of our using directives and the namespaces below? Okay. Above, we have our directives reference existing namespaces. So they have to be somewhere else. Below, which is the namespace that we're working here now, we are creating a new namespace and defining its elements. Okay, so that's what this namespace line is doing. By default, it's going to have the same name as the document that we've created, the solution that we've created. Okay. Then we're going to have internal class program. So this is a first creation of a class within a namespace. We define classes, which have what? Properties and methods. All right. Now, our program in and of itself, we think about this abstract concept of a program that's going to be running. It doesn't really have any properties necessarily that we're going to assign to it, but it is going to have methods, stuff that can be done. And specifically, this one that it has auto-created for us and already populated because it just wanted to do that. It's creating what's called the main method, which is the method that's going to execute by default. And yes, you can change that in the program settings to run something other than main, but that is the one that it is looking for. Put a comment there. This is the main method of the class. It's also the root of the program. Now, normally I would have asked, what is the code to write hello on the screen? And we would have, as a group, tried to figure that out with the limited knowledge that we have. But since Visual Studio is just too smart with its integrated AI, it says, oh, this is what you want here. Okay. So let me break down this line here so that we can kind of see what's going on. Console is how we refer to the command line environment that this program is going to run in. The write line is actually going to export a line of text to the command line interface, and then the parameter that we pass to write line is the text that it actually writes. Let's try something really quick. I'm going to delete write and just, or write, I'm going to delete line so that we just have write. Okay. Do you think it will work? There's no red squigglies. Right? I can either hit F5 or hit the solid green play button up here at the top in order to compile and run the program. And it did in fact work. Is it any different than it was before with write line? Let me run it again. There's an extra line here when we do write line as opposed to just write. Okay? If we just do a write, it puts the text on the screen and it does not move the input to the next line or the output to the next line. So that's why that line is missing. Now the code, in order to prevent this from just disappearing, is throwing up this little message. This is added by Visual Studio. Okay? And it's also a change in .NET 8. .NET 6 and 7, it would just close if the program was done. Okay? Which I kind of prefer. I'm curious how smart it is. If we wanted to keep the console open, okay, I'm going to do a console.read, open close paren, and a semicolon. Read is how we get information from the user. I'm not storing it anywhere, but this should allow me to get a write line, hello world, and now it's just sitting there kind of waiting for the program to get some input. I hit enter, and that's the piece that I really kind of wish wasn't there. We're going to have to close it that way every time. That'll work. So if the console was automatically closing, we could request some user input in order to keep it open, but we don't need to do that anymore. Right. It's not storing it in a variable, it's just waiting for input. It's not going to do anything with the input, but it's just going to sit there and wait for input. Right. Yeah, and we'll look at actually getting user input in a moment. Okay. Okay. Let's talk a little bit about what we can do inside of C# from a basic sense, start to get our feet wet a little bit. First thing that we have is variables, right? We need to be able to create variables and assign values to them. The way that we create variables inside of C# is by first defining the type. So if I want a string, for example, okay, I want to define the type, then I need to give it a name. Don't forget good camel case. And if you have some contextual clues as to what kind of variable you're creating, that's a good thing to do. So I'm going to create string str name, and I'll set it equal to Stephen. Okay. Now you may be noticing that I am ending my lines with a semicolon, and if you don't end your line with a semicolon, you get a little red squiggly at the end of your line or the beginning of the next one. So you're learning already that in C# we need to end all of our lines with a semicolon. You'll also note that we're using curly braces to encapsulate things like methods, classes, and we will use it later for conditionals and loops as well. Okay. We also have things like an integer. Put my age. This is where I ask you guys, how old am I? Anybody want to take a guess at how old I am? 38? Andrew, how old am I? 42. Answer the life, the universe, and everything. Eli?
40. I'm taking the median.
Well done. Yep, no. I'm apparently a little older in your guys' mind than I actually am. No. All right, 35. Now if I do a console.writeLine, okay, and we notice that IntelliSense is kind of trying to help us out, like this is probably what you mean. Okay. We got to be careful because look at what it's trying to give me this whole string now. Okay, it's not entirely what I want. I do want to do a write line. I don't want to do the whole write line, so I can't not take all of its suggestion. If I want to go ahead and put in those names, let's do a string literal. Hello. My name is, and then outside of that literal string, I'm going to use a plus sign in order to append. And let's just try this. str name and age. Think it's going to work?
No.
Yeah, okay. In like Python, this would break because it's going to try and do math as soon as it sees a number, right? Okay. It does do a background to string. That's an interesting piece that sometimes it won't do. Okay. All right. Real quick, just so that you have a record of some of the different variable types that we have. String, that's where we can put in some set of characters. Okay. What about a char? What's a char? It's an individual letter. Now you'll notice that when I did that, it like auto-completed. Look how it wants to do it. It's like, I know what you mean. I know what you're doing. We're going to do this. And by the way, does your guys' have the same suggestion there?
No.
Okay. Mine has that suggestion because I have written code that looks exactly like this before. And it knows that, and it's completing it based on the stuff that I've written before.
I don't like that.
That is both helpful and terribly annoying.
I keep like wanting to press tab, but then put something there that I don't want.
You gotta be careful with that tab completion. It's not always as helpful. Okay. Notice that this used single quotes rather than double quotes. If I do something like an A inside of double quotes, it complains. We've got a red squiggly. Let me see what the red squiggly says. Cannot implicitly convert type string to type char. But it's just a single character. Right? It's not. If it has the double quotes, that's a string. Single characters require single quotes. Similarly, if I try and change this to single quotes, it's like, nah, that is not okay. We get a little red squiggly there as well. Too many characters. Too many characters in the character literal. So in C#, we have to use double quotes for multiple characters, single quotes for single characters. Okay. Numbers. We've got our int, okay, and that is a whole number, positive or negative, like a 5. All right. If I want a decimal number, a floating point number, we do have a float. Call this one a float number. Now, if I try to do 5, it seems to be working. If I do 5.0, ooh, there it is. All of a sudden I get an error. Now wait a second, isn't floating point supposed to have a decimal? A double works, but why not a float? What's the difference between a float and a double? So double is short for double precision floating point number. Float is a floating point number or a decimal number. So why is it complaining? And it might help if you mouse over that red squiggly and see what it says. Literal of type double cannot be implicitly converted to type float. Use the F suffix to create a literal of this type. Interesting. So by default, if it sees a decimal, it's going to make it a double.
Implicitly?
But, automatically. But, if you want something with less precision, a float, it says that's a double. So we need to add a letter to the end of that.
Wow.
F denotes floating point. Decimals are interpreted as double by default. Okay. There is another one, decimal. What in the world is a decimal number? And why doesn't it like it?
Does it also make it something?
It also thinks it's a double.
Or double, yeah.
Yep. We need to add an M to the end of that one. M denotes decimal, extreme precision. A decimal number has crazy precision, and I forget what the actual number of digits is, but when we do some of the other math stuff that we're doing, we're going to find that like the float might have 8 to 16 decimal places. The double has like 16 to 32. The decimal has like 100 decimal places. It's an extreme precision decimal number. All right, that is all the time that we have for today.